Good day. Um, Today's topic is solving an equation by using factorization. So in this case, it means that we are looking at an equation, and this equation can be solved by using factorization. Right, then the example that we have here says here, solve the following. 1 over 3 x squared minus 3 is equals to 0. Then number 2, it's x into x plus 2 is equals to 0. That's the second equation. So these are the two equations that we are going to make use of so that we try our level best to understand what happens whenever we are using factorization to solve an equation. Now, personally, whenever I'm solving an equation where factorization is needed, I follow certain steps, all right? So the steps that I follow are as follows. 1, I write all the terms on one side of the equal sign, right? So that part of terms which is on one side will be equals to 0, which means the terms form an expression, then it is going to be equals to 0. So in other words, I will equate that expression to 0. Then after doing that, if there are fractions, I will then get rid of all the fractions. That is if they are there, right? How do I get rid of the fractions? I make use of the LCD, which means I multiply each term by the LCD. Now, after multiplying by the LCD, then my expression is not going to be in the form of fractions, which means the whole equation is not going to have fractions in it. It's easier on my side whenever I'm dealing with equations that is got fractions. I first of all clear or get rid of the fractions so that my equation become easier. Then I will identify the type of an equation that I will be having or that I need to solve. So knowing the equation, it can lead me to identify the method to solve the problem. In this case, it's factorization. So it will be easier for me to identify a factorization method that I may use to solve the problem. Then step number 4, I have to factorize. That is, if it is not factorized, I must factorize it so that I can then solve the problem by using factorization. Then step number 5, equate each factor to 0. Now each factor in the factorized expression part is going to be equated to 0. Remember, our equation is having all the terms on one side and it's equals to 0. So when I factorize, I'll then have to take each factor and equate it to 0, which means it is equals to 0. I'll explain more on this point or step number 5 when solving the above two equations. Then we move on to number 6. Number 6 says solve each factor. Now, so after equating each factor to 0, we then have to solve each factor, which means we're going to find the value that makes each factor to be equals to 0. What is that value? So we have to solve each factor. Then number 7, I am now having solutions or answers, which we call roots in most cases when we are dealing with equations. So these roots will then form a set of answers for the equation. So we call them root or roots, right? Then, before I finally say this is now my set of answers or roots to the equation, I must then do number 8. Check the roots whether they are correct for that particular equation or not. If they are correct, it means the left-hand side is equals to the right-hand side, right? But if the right-hand side is not going to be equals to the left-hand side, then it means your roots are wrong. So you have to start afresh up until you come up with roots or solutions or answers that can make the right-hand side to be equal to the left-hand side of the equal sign. Then it means your solutions are all right. Now, starting with the first example here of an equation, it's 1/3 of x squared minus 3 is equals to 0. Now, in this case, it is not factorized. Then again, we are having fractions. So the first thing that I'm going to do is to get rid of fractions. How do I do that? It means I have to multiply by the LCD. What is my LCD there? Now, my LCD comes from the denominator. So it's denominator 3 here, and here it's a whole number, which means denominator is 1. So the LCD for 3 and 1. The LCD becomes what? For 3 and 1, remember I'm saying I must first of all find the LCD. What is my LCD there? My LCD becomes, remember the LCD means what? Lowest common denominator. So this is the LCD of what? 1 and 3, which is equals to 3. That's my LCD. Now, so I'm going to multiply each term by 3 so that I get rid of denominators, or so that I get rid of fractions. Now I've multiplied each term by 3. Remember, my idea is to get rid of fractions. Then the first term multiplied by 3, it means 3 times 1/3. It goes to 1, which means my first term becomes so my first term will now be equals to x squared. Sorry for the shapes there. The shapes are not all right. Sorry. Forgive me for poor shapes. Then 3 times 3, we come up with 9. Then 3 times 0, we come up with 0. Now, Then from this, now I can now see clearly the type of equation that I'm dealing with. Now it's x squared minus 9 is equals to 0. So it means in this case now, we are dealing with an equation that has got two terms on the left-hand side, right? Now, since it is two terms, what type of an expression is on the left-hand side? It means this type of an expression is called binomial because it has got two terms only, right? There are two terms, which means it's what? Binomial. Now, when we check the two terms here, there's a negative in between, right? So because of the two and the negative, the first thing that comes into my mind is I'm dealing with a binomial. So since it is a binomial, there is a negative, which means difference of two terms. Now, I suspect that this is a difference of two squares. That's what I suspect. So now I have to check first and find out whether they are perfect squares. If they are perfect squares, then it's difference of two squares. Then let me check. This is x squared. X squared, it's a perfect square. Minus 9 is the second term, and 9 is a perfect square. So it means this expression part of the equation is difference of two squares. So it becomes very easy for me to factorize it. So for the sake of explanation, what is the term or the value that I am multiplying twice to come up with x? It's what? It is x. Here I'm just showing that the number that I am dealing with in this case are perfect squares. So I must find the numbers that I am squaring to come up with what? The perfect squares that I am having. The number that I am squaring to come up with 9, it's what? 3. So it's 3 squared. So it's x squared minus 3 squared. This shows that they are perfect squares. Now, so since they are perfect squares, it becomes very easy for me. My next step is to distribute the two numbers in the brackets. I'm going to distribute the numbers that I am squaring, right? Then I will now say my brackets. Let me make use of these letters, which are now easier. It's now easier now. Right. So since I am dealing with an equation that has got difference of two squares, then I'm now going to say my bracket I'm going to come up with brackets. Then I will then distribute the numbers, right, into the brackets. So that's my first pair of brackets. Then my second pair of brackets. Why am I doing this? I'm doing this because I've seen that my numbers are, or my terms are perfect squares, right? So I'm just going to distribute the numbers that I am squaring into these two brackets. What are these numbers? Here I'm squaring x, so I will distribute x first. Distribute x first. That's x in the first bracket, and x is my first term in the difference of two squares. So it is also going to be what? The first term in the second bracket, which means I have x there. I have distributed x. Then the next one is what? 3. 3, I'm squaring 3 to come up with 9. So I'm also going to distribute 3 into the brackets. Now, this method that I'm using to factorize a difference of two squares, it's only true for a difference of two squares. I repeat again, this is only true for difference of two squares, right? So I can factorize it by using this method that I've just used. Now, then from there, since it is difference of two squares, one bracket must be positive, must be having a positive operation, and the second one must be having a negative, right? So I can then just say, let the first bracket here have what? A positive sign. And the second bracket, let it have a negative sign. Right? So in this case, I factorize difference of two squares. So remember I said this method is only true for a difference of two what? Squares. Right? Now, then from there, I'm now going to equate each factor to 0. So the factor that I have here is x plus 3, and this second factor is x minus 3. So these two factors are multiplying each other. That's what we call factorization. Whenever you factorize something, it means you are expressing it as a product of its factors. So the first bracket is the first factor times the second bracket, which is the second factor. So these two factors are multiplying each other to come up with 0. Right now, so I've just said my next step is to equate each factor to 0. Why are we equating each factor to 0? The reason is, if you can check here, these two factors are multiplying each other. So when you multiply these two, you come up with 0. So if the first factor, x plus 3, is equals to 0, in other words, if the bracket is equals to 0, it means it's 0 times the second bracket. Any number multiplied by 0 gives you what? 0. That's the reason why we are saying if the first bracket is equals to 0, then we multiply by 0 to come up with 0. Then if it is the second bracket which is equals to 0, it means x plus 3 times 0. It also gives us what? 0. That's the reason why we have to equate each factor to 0. So it's x plus 3 is equals to 0. Now, if the first bracket is not equals to 0, then it means what? It means then that it's the second bracket which is equals to 0. Now, I'm going to start with the first factor first, all right? X plus 3 is equals to 0. If the first factor is equals to 0, then what is the value that makes it to be 0, right? Now, which means I'm going to transpose this 3 here. I transpose the 3 so that it goes to the right-hand side, right? And whenever you transpose the whole term, it means it will take the opposite operation. What is it going to be? It means then that my x is going to be alone, which means it becomes x is equals to, remember the 0 which was there already, then the incoming term, it becomes negative 3, right? Then I simplify the right-hand side, which means my x is now equals to 0 minus 3, which is negative 3. So that's my first solution, which means this is my first root, right? This is one of the answers that will make my equation to be equals to 0. Then let me go on to the second factor. Now, from my second factor, it means I'm going to transpose what? I'm going to transpose this negative 3 so that it goes on to the right hand side. Now, when I transpose that 3, I am transposing the whole term. So it means I'll be having x, which is equals to, then the 0 which was there. Now, the negative 3 that we transposed, it went over the equal sign, isn't it? Which means it becomes what? Positive 3. Then we simplify the right hand side, which means x is equals to 0 plus 3, we come up with 3. Then there's no more any other simplification to be done. Then I am now saying, the first one says x is equals to negative 3 or x is equals to what? 3, which means my solution set is now equals to what? Then it is equals to x is equals to, I always start, or we are supposed to start with the smaller or the smallest one. Then my smaller one is negative 3, or it is equals to what? It is equals to, that's 3. So this is my solution what? Set now. In other words, I am saying our answers are from these two values or these two roots. But before I conclude to say these are my answers, we can do the checking, right? Now, when we are checking, it's just a matter of substituting here, right? When you substitute negative 3, multiply it twice, you get positive 9. Positive 9 times 1/3, you come up with positive 3. Positive 3 minus 3 gives you 0. So 0 is equals to 0, which means negative 3 is all right. Then you check again with what? 3. 3, multiply it twice. You are squaring it. You come up with 9. 9 times 1/3. 1/3 is the coefficient of x squared, right? So 1/3 times 9 is 3. 3 minus 3 is 0. 0 is equals to 0. So it means my two roots are fine. In this case, I've just done the checking without substituting it and showing it on the paper or on my script, right? So it's very, very important to avoid mistakes. Just do it on your what? On your script, and make sure that it is correct. Now, then when writing equations, some learners do make mistakes by writing another equal sign, right? You'll find out that some learners will write equal sign here, here, here. Don't write that equal sign here on the edges of an equation. The equal sign is already in. This is the equal sign, which is inside. So that equal sign is already in, it's covered, right? Now, let me now work out number 2. Forgive me again, I'm going to write it side by side here, right? But normally I don't encourage you to do side by side. You should move on to the next what? Page. This is for correction purposes, right? Now, so let me then do it side by side here. Right, number 2. If you still remember my number 2, my number 2, we are given an expression which is x into x plus 2 is equals to 0. Now, if you check on this second equation, you can see here that on the right-hand side, there's equal sign. There's nothing there. It's 0, right? Which means all our terms are where? Are on the left-hand side. And if you check on the left-hand side, it's completely factorized. So there's no need for me to factorize again because it's completely factorized. Right, which means it's easier on my side. I'm just going to start from what? From step number 5 now, and I move on. So since it is completely factorized, I'm just going to equate each factor to 0, right? So in this case, it means my first factor is x, which is equals to 0, right? If it is not the one which is equals to 0, it may mean then that it's what? Is the second factor which is inside the bracket which is equals to 0. So my second factor is what? It's x plus 2. Let it be equals to 0. Right? Now, I've got two factors, x and x plus 2. So my x is equals to 0. I cannot do any other further simplification. So it's okay as it is. Then I move on to my second one. My second factor is x plus 2 is equals to 0. So for me to solve for x, I must transpose what? I must transpose 2. So it means I'm going to move the 2 to the right-hand side. Right. So when I move or when I transpose 2 to the right-hand side, what am I going to remain with on the left-hand side? Or factor number 2. It means it's x, which is now equals to, then I add 0 initially. Then the 2 that I'm transposing is positive. So since I'm transposing the whole term, it means it is going to be what? Negative 2. Then from there, I simplify my right-hand side. 0 minus 2, we get negative 2. Now, what is my final answer now? According to the equation that I have there, my final answer becomes what? That's the set of solution now. So my x is equals to, the smaller one or the smallest one is what? It's negative 2. Or, because we are having two solutions, or 0. These are my set of solution. And remember, I once said, before you conclude that this is your answer, you must first of all check your answers, right? Check your answers and find out whether they are correct or not. Now I can just do a quick check by just substituting it here. Now, take the first root, substitute it here. It's negative 2. Negative 2 times what? Times the bracket. The bracket is negative 2 plus 2. Negative 2 plus 2, it gives us what? 0. 0 times negative 2, it's 0. 0 is equal to 0. Left-hand side is equal to right-hand side. Perfect. That's good, which means it's correct. Then you take the 0. X is equal to be 0. Sorry for that. Now, the second factor is 0. X is equal to 0 here, and this is 0. So it's 0 times 0 plus 2. I cannot wait to simplify inside the bracket because the outside number is what? Already 0. So 0 times the bracket gives us 0. 0 is equal to 0, which means my second root is also what? Correct. So that's how we deal with what? Solving equations by using factorization.